Today's section will be about right triangle trigonometry. So just a little bit of review. You probably remember learning SOHCAHTOA from last year, and you can still use that to remember the important things, sine, cosine, and tangent. Don't forget that sine is going to be the opposite over the hypotenuse. And looking at the triangle on the side, you can see the angle theta. The hypotenuse is the longest side. That's always going to be the case with the right triangle. The opposite and the adjacent are going to depend on where the theta is. So in this one, the adjacent is the closest side to that theta. The opposite is the one that's opposite it. Occasionally you will see a triangle and you'll have the theta in a different place. If that were to happen and you had a theta right there, the hypotenuse wouldn't change, but the adjacent would actually be still the one next to the theta, but in this case it's a different side, and the opposite would be opposite from the theta, once again, different side. So just make sure that you are aware of which angle you're working with and where your opposite and adjacent are. So that's our sine is opposite over hypotenuse. The cosine is going to be the adjacent over hypotenuse, and the tangent is going to be the opposite over adjacent. Now, I've listed the side ratios for the next three things, but actually rather than memorizing that cosecant is hypotenuse over opposite, I would recommend that you just remember that the cosecant is the reciprocal of the sine. It is a lot easier just to take the reciprocal than it is to try to memorize three additional things. And same thing, the secant is the reciprocal of the cosine. And the cotangent is the reciprocal of the tangent. And you can see that based on their definitions here, but like I said, if you just remember that what they're the reciprocal of, that'll be a lot easier than memorizing further definitions. For our first example, we are going to find the values of the 6 trig functions of theta that are shown in the figure. So what we're going to be looking for is we're going to be looking for all of the different ratios, for example, for sine and for cosine and for theta. You might be able to see what the sine is immediately. However, in order to get all of them, we should also find that other side. I'm going to call this side down here x. So in order to find x, the first thing I need to do, this is my step 1, I need to find the missing side, and you might remember from previous classes that you can find the missing side using the Pythagorean theorem. You are allowed to do that in this case because we have a right triangle. So just a little recap. The Pythagorean theorem is a squared plus b squared equals c squared. The a and the b are going to be the two legs, which are the shorter side of the right triangle, whereas the c is going to be the hypotenuse. So in this case, my c is equal to 4. It actually doesn't matter whether you call 2 a or b, but the c is very important. So I'm going to say c is 4. So I'm going to write this out as 2 squared plus x squared equals 4 squared. I just need to solve this one out. I end up getting 4 plus x squared is 16, and I end up getting that x squared is equal to 12. So I need to take the square root of both sides. And remember, when we're working with sides, we don't need a plus or minus because the side lengths are going to be a distance, a length, and so we're just going to only worry about positives in this case. The final thing I'm going to do is I am going to rewrite the square root of 12 if you remember, that's the square root of 4 times the square root of 3. The square root of 4 is 2, so my new side is 2 radical 3. So I'm going to write that in right there. From there, now that I have all sides, I can actually find all of my trig functions of theta. So I'm going to use that as step 2. So step 2, I'm just going to find my trig functions. I find the sine, and the sine is the opposite over hypotenuse, which is 2 over 4, or 1/2. The cosine is my adjacent over my hypotenuse, which is 2 radical 3 over 4. I can actually reduce that to radical 3 over 2. I'm also going to find my tangent. My tangent is my opposite over adjacent, which is going to be 2 over 2 radical 3, or 1 over radical 3. And when I simplify that, I get radical 3 over 3. So now comes, I have the first 3, now comes the reciprocal trig functions. So rather than trying to think about it as something like cosecant is hypotenuse over opposite, all I'm going to do for the cosecant is I'm going to take the reciprocal of the value I got for sine. So for sine, I got 1/2. Cosecant is just going to be 2 over 1, or 2. For the cosine, I got the square root of 3 over 2. For the secant, I'm going to find the reciprocal of that. I do need to go further, and I get 2 radical 3 over 3. And then the last one for my tangent, to find the cotangent, I just need to take the reciprocal of the value that I got for tangent. And a little trick that I can use is I could do the reciprocal of radical 3 over 3, or even easier than that, I can look at my unsimplified version. I know that the reciprocal of 1 over rad 3 is radical 3 over 1, which just gives me radical 3. A lot easier to deal with. For my second example, I am actually given cotangent of theta equals 5 over 12. I need to find the other 5 trigonometric functions of theta. What that means is I am looking for everything else. I'm looking for sine theta, I'm looking for cosine theta, tangent theta, cosecant of theta, and secant of theta. So in the end, I need all 6. I already have one of them, now I need to find the others. So the first thing I need to do for this type of problem is I need to sketch a right triangle. And I'm going to draw my right triangle. I'll put my theta right here. And so then what I know is that cotangent of theta is 5 over 12. To be honest, working with cotangents is a lot harder than just working with tangents. So if you want, you can rewrite it as tangent of theta equals 12 over 5. This is much easier to deal with. So we know that tangent is equal to the opposite over the adjacent. So what I'm going to do is I am going to draw my opposite as being 12 and my adjacent as being 5. And actually the triangle I drew, it looks like the sides are about the same, so I'm going to change it a bit and make it look more to scale now that I know that my adjacent is a lot smaller than my opposite. So here's my theta. My adjacent angle to the theta is 5. My opposite angle to the theta is 12. So now I have my right triangle started. So that's my first step. My second step is that I need to find my missing side. And you might be able to guess that based on the previous example, I can use the Pythagorean theorem. So in this case, it's my hypotenuse that I don't know. So I'm going to do 5 squared plus 12 squared is equal to c squared. When I do that, I get 25 plus 144 is equal to c squared, or 169 is c squared. So in this case, I will find that when I take the square root, I will end up getting that my c is equal to 13. So I now have my third side. So the third step for this problem is to find the other trig functions. Actually, I already found the tangent because I had been given the cotangent and I just took the reciprocal of the cotangent. So I know that the tangent is 12 over 5. So now I just need the other 4. So my cosine, or my sine, remember, is going to be the opposite over the hypotenuse. In this case, the opposite is 12. The hypotenuse is 13. And actually, I'm going to also find my cosecant at the same time because I know that to find cosecant, I just need to take the reciprocal of the sine. So cosecant is just going to be 13 over 12. Cosine now is going to be the adjacent over the hypotenuse, which is going to be 5 over 13. And then I can also find its reciprocal, the secant, which gives me 13 over 5. And that's actually all I have to do on this step. I'm done. And this is the rest of the problem. So now I'm going to go over a few things that I actually want you to have memorized. So these you are going to have to be able to do by heart. The good thing is there are some tricks to remember them. So my first one is sine of 30 degrees. So sine of 30 degrees is going to be 1/2, and actually that's going to be the same as cosine of 60. So if you want to remember that sine of 30 and cosine of 60 are equal, you can. The same thing happens with sine of 60 and cosine of 30. Both of those are going to be equal to radical 3 over 2. So you can remember that with 30 and 60. The next thing that you're going to have to know is sine and cosine of 45 degrees. You might remember this one from the unit circle. So both sine and cosine are going to be radical 2 over 2. So hopefully you can remember that sine and cosine, when they're both 45, they both have the same value. The next thing is the tangent. So now, one thing you can do, if you really cannot remember all of these things, one thing you can do for tangent is remember that tangent of something is always going to be equal to sine over cosine. So you can be able to work them out from that. And we'll start with the tangent of 45 degrees. So sine of 45 is radical 2 over 2. Cosine of 45 is radical 2 over 2. Actually, that one is wonderful because when you divide those two, when you do sine divided by cosine, you get 1. Tangent of 60 is a little harder, but you can still divide them out. When you divide radical 3 over 2 divided by 1/2, you just get radical 3. When you do the same thing with 30 degrees, tangent of 30 degrees, you end up with 1 over radical 3, which gives you rad 3 over 3. So these ones you are going to have to be able to use. So just make sure you know these 9 things, or that you can figure out these 9 things. So we're going to use these in a few examples. So for my first example, I am going to ask you to evaluate this actually without a calculator. And I'm actually going to give you 2 examples here. And I'm going to say solve for the missing side. And I'm going to actually say missing sides. And the other thing I'm going to say is that you may not use a calculator. So this is number 3. I am going to ask you to find the value of x and the value of y. So the first thing is that this is by the way, that's a 45. This is a special triangle. It's a 45, 45, 90 triangle. And in those type of triangles, this is also going to be 45. So if you have a 45-degree angle, just watch closely on the next part and make sure you understand that if you have a right triangle and one of your angles is 45 degrees, the other one's going to be 45, and the triangle is actually isosceles, which means that this y down here is going to be equal to 8. Same thing as the other small side, the other leg. So actually from there are now, once you get that 8, there are actually 2 ways to do this problem. One way you can do gets you around having to do sine and cosine. So I'm going to show you both ways, and it's going to be your choice what you want to do. So the first way is to use that sine of 45 degrees is equal to the opposite of that 45-degree angle, which is 8, over the hypotenuse, which is x. So I have set up an equation that you can use here. From there, we are going to simplify this using what we know about sine of 45 degrees. So sine of 45 is radical 2 over 2. Now I have that equals 8. From there, I am going to solve this using the cross product. I get radical 2 times x equals 8 times 2, which is 16. I divide both sides by radical 2, which gives me x equals 16 over radical 2. I just need to solve it out by multiplying by radical 2 over radical 2, which gives me 16 rad 2 over 2. And my final answer is 8 radical 2. So the second method to do this, which actually is a lot shorter, or maybe shorter, depending on what you're good at, is that you actually, in the beginning, once you got that y was equal to 8, you actually can figure out x by using the Pythagorean theorem. So both methods would have worked for this problem. All right, let's try number 4. So number 4, we have a triangle. This side is 4, this is x, and I'm going to tell you that this up here is 60 degrees. So from there, I am going to ask you to find x. I'm also going to call this side right here y. So just a note on this problem. If you don't like the way if you don't like the place that the 60 degrees is written, you actually are allowed to rewrite to find the other angle in there, which, by the way, will be 30 because all 3 angles need to add up to 180, and use that one and do the trig functions of that one. For this problem, it will be your choice which one you want to do. So I'm going to start by finding that x. And I can find that x one of 2 ways. I can either use the 30 degrees and say that sine of 30 degrees equals the opposite over the hypotenuse, which is 4 over x. My other option is to use the 60 degrees. For the 60 degrees, the 4 is adjacent to it. So I can use cosine of 60 equals 4 over x. And believe it or not, doing these 2 methods will give you the same exact answer. The reason that will work is because sine of 30 and cosine of 60 are equivalent. So let's go ahead and finish this up. I'm going to do it just using the sine of the 30. And if you look above, sine of 30 is equal to 1/2. I get 1/2 equals 4 over x. Thankfully, the rest of the problem isn't too bad. All I need to do is find the cross product. I end up getting that x equals 8. And I can put that on there. The last thing I need to do to solve this is I have to find this y. And to find the y, I am going to use the cosine of 30. You can also use the sine of 60. So the cosine of 30, and have that be equal to the adjacent, which is y, over the hypotenuse, which is x. So cosine of 30 is radical 3 over 2. I get that that equals y over 8. I end up getting, I'm running out of room unfortunately, so I'll write it up here. I end up getting that 8 radical 3 equals 2y. I got that by doing the cross product. So the final answer, I need to divide both sides by 2. I get 4 radical 3 is equal to y. And that gives me my two sides.